Hi everyone, things are going today. So I'm making this little part to use inside the Z bracket. What I'm looking for is something that drops in. Alright, let me show you really quick. So I can take a nylon nut, insert it into the part as such, and then you would slide it into, let's see, I have cameras all over the place today. Ooh, that fell out. Okay. So it would go into a relief. Right? Goes into the relief. And then it just slides into this. And you have two through holes for the bracket, for the bed to come up and down for Z-axis. And you have this bracket to mount the rails on. So I made, I'll upload the whole video of me designing it and then printing it, test fitting it, doing a couple of revisions. So I print a little smaller one. Alright, goes in, nice and easy. Go grab the second bracket. Doesn't fit. Right, you can see that. Goes in. Tight fit or no fit. I mean, I can hammer it in, but that's not what I want. Loose fit. Alright, so if we measure these really quick, I'm gonna check the outside dimensions of this, of the larger one, and I am getting 19.99 millimeters and 20.04 millimeters. On this one I'm getting 19.66 millimeters, 19.82 millimeters. So that's quite a bit smaller. And if outside dimensions are smaller, of course the inside dimensions are smaller. Normally, from my understanding, when these are extruded, right, because this is an extruded piece of aluminum, you will most likely, especially that's how you do in plastic, is you tolerance the outside dimensions and the wall thickness, right? So this is what we have. So what I'm gonna do is for this bracket right here, the little holder, is I will make, I'll upload it to Thingiverse, and I'll make different sizes of these. So they'll just change. I'll probably go from 3.5 in quarter millimeter, not tolerances, quarter millimeter versions, all the way up to 14 millimeters, so that you guys can measure and just print out, or you can just print the tool. I have not a lot of free time, but I like to tinker and make these kind of things to make assembly a little bit easier. And if I need to retighten it, everything's already in the 3D printer to do so. I'm not sure how you could get that little tool in there, especially if the nut moves, then you'll never be able to orient it correctly. But if this stays in with the nut, you always can tighten it later on if you wanted to, or change the screw or do whatever the hell you want to do with it. So that is it. Okay. So we're just zooming in on the frame of the Sk-Tank. As you can see, the bracket I made is for the white bridge, which is on the left and right side of it. This is a quick description of what you need to assemble it, which is 5 by 30 millimeter bolts, 5 by 10, some nuts, flange nuts. I ended up using, once again, nylon nuts for this with a nylon lock, and the printed M5 holder, which you would not use if you use the part that I put together, designed. So it just kind of goes over, you have one short bolt going through over here on all the way to the right, and then you have the longer ones in 3 other locations that go through the bracket and secured with a nut on the back side of the bracket. Looks like the reason for one being done inside the Y bracket is so that the nut doesn't stick through, so you can mount your Z holders on the back side. This again shows you the nut that is secured on the inside of the Y bracket. And this is the reason why, I believe, is you see that bracket at the top, it's held by 2 screws that are going all the way through. So you need, for it to sit flat, that's the only way to do it. And you do use 5 by 30 with 2 flange nuts, or once again, I would use the nylon lock. So I use Inventor. I believe it's most likely one of the best 3D modeling packages. Second best, I believe, is SolidWorks. And the worst would be Creo. I have used Creo for a few years. It is extremely unintuitive in comparison to the other two. So at home, for my 3D printing, for modeling, for anything, I use Inventor, mainly because I have access to it, and secondary is it is fantastic. All right, so in the little screen on the bottom right corner, I'm measuring the inside dimensions of the extrusion. They're around 14 millimeters, and then I check the hole ID, which is around 5.20. So I check all 3 to make sure they're correct. Well, make sure they're all the same, basically, or as close to the same as possible. And I'm just going to create a new part. It's a standard part. You hit create. It loads in a new part. My Inventor automatically defaults to standard measurement system. So just go in there and change it to millimeters. So here I change it to 14 millimeters. It's a little bit sped up, so I'll try to speak really fast too. So I measured how long the bracket should be. It looks to be around 35 millimeters. Or the insert, whatever you want to call it. I put a little fillets on them so that it is easier to fit into the extrusion. I was gonna draw out how I was measuring the holes, but decided that's probably not such a good idea because I can probably just do it in Inventor. So I'm doing a sketch on the side of the part. I know they're halfway up, so I know that all 3 of them are going to be 7 millimeters high off one of the corners. And then my first mistake that I did here is I measured to the corner. Right, so you see right there. So I normally measure to the center of the hole or the circle, because if you want to change the diameter of the hole, it will still be centered. If you measure it to the side and you change the diameter of the hole, it'll actually shift, it'll offset. So I initially do this, and then later in the video you'll see me changing it to measuring off the center, because I did need to modify the hole diameter a little bit, which would have offset it and would have not worked. So I just extrude all the way through. It's just through cut. Now I'm gonna grab the polygon. I place it and I make sure that those 2 lines are parallel, so it rotates it in the perfect position. The best way to find dimensions of everything is just go to McMaster, right? Especially about the nuts there. But even if you didn't, it's a perfect source to find dimensions for all of the hardware that's out there, because it's pretty much a standard. So this is the first design that I automatically redesigned right after doing this extrusion, so don't really pay attention to that. I was going to extrude it like that with a hole, and then I realized, well, to give it a little bit more strength, I should probably have the nut completely encompassed in plastic. So I'll go through all this really quick, do the offset, and then a minute later realize my mistake, and then I delete and start over again. Right here I look at it, it doesn't really make much sense to me. I'm thinking about it, and then I just do a little bit of mods. This is when I also realize that it's going to be offset when I increase the diameter. Okay, this is where I decided to delete. Start over. Right, so I can just do an extrusion. This keeps the insert from going too far in. Then I think, oh, I'm just gonna extrude, the sum of it and not all of it, so that it doesn't interfere. And then I look at the bracket and I measure the wall thickness. The Y bracket, the wall thickness, so it is around 3 millimeters. So if it sticks out by 1 millimeter on the flange of the insert, it doesn't really matter. So then I do that and extrude it. One mistake I did right there. So I did 6 millimeters, but it was 6 millimeters in and out. So it was actually cutting 3 millimeters in when I needed 6. And I found that out really quickly after I printed it. What you should do is to actually do an assembly inside of Inventor. You can download the step of the nut and actually assemble it into the part, and you would have quickly found out that that extrusion did not go as far as it needed to go. I did not do that. I skipped that step, so I only found out about 45 minutes later after it printed. So this is where I make my OD changes, and then I most likely measure everything to center instead of the corner of the circle. So it's half of the diameter plus the distance from the corner of the hole to the end of the Y bracket. So that's what I'm doing. I know I measured them when they're around 5.2 divided by 2 plus whatever the distance is to get to it. And all of that lined up perfectly. And then I tried using that measurement as a check. Of course, the second I put it in, I realized that that would not be the same as the part because the hole diameter that I ended up using is actually larger. Then you just make a folder to keep everything nice and tidy. I saved the part. Then you do the 3D print positioning, and then I save it STL. I had to make that a little bit smaller for it to fit into the bracket, easily fit. So it's not a press fit, it's more of a loose fit, which was what I was looking for. And then I did, so this is the first part I printed. As you can see, it's a little tight, it doesn't go in. And I'm just going through and verifying to make sure the part is gonna work as designed. I use Cura for 3D printing. So you just put the part in, put slice. My Creality Ender 3, highly modified, is all programmed, ready to go. I normally print PETG. I use Octoprint to control my printer remotely. I also have set up a smart outlet that's built into Octoprint to turn it on and off. One nice feature of that is when the print is done, Octoprint will actually shut off your 3D printer, so it doesn't just sit there running. So part of the G-code addition at the end is to turn off the printer. Alright, so here we go. My printer is heated up and ready to go. Right now it's doing the bed leveling, or whatever it's called. It's not really leveling. And there goes your print. You can watch it, enjoy it. It's sped up 10 times. It took around 45 minutes to print this one part. It's a pretty cool color. It is a translucent blue PETG, and I purchased that from Matter Hackers, which is the source for a majority of my filaments. Mainly because they are, I think they're fair on their price, and the quality's been great. I run the PETG that I purchased from them at the same temperature, at the same everything, and it runs fantastically. That is it. That is all I got. If you have any questions, just leave a message below, and I will respond when I see it. These brackets are uploaded to Thingiverse. Just search for Sk-Tank and you will find them there. I created multiple sizes because I found out that the extrusions, the Y bracket extrusions, have different, they're not identical. The dimensions are a bit off. The outside dimensions and inside dimensions are not the same. So when I made a bracket and had a perfect fit into the one I showed you in the video, when I went back to the workshop and I tried to plug it into the other side, the other bracket, it would not fit. So then I took some measurements to realize that, and because of that I created 5 or 6 different sizes on Thingiverse, going from 13.5 millimeters up to 14 millimeters. So just measure and pick. You do not want to do line on line, right? So if you're measuring the inside dimension of your Y extrusion and it's, let's say, at 13.7, you do not want to print a 13.7 bracket. You want to print a 13.6 bracket because line on line is not a good fit. That is all I got for today. Let's see what's gonna happen next. Today's the 18th, so on the 28th I should have my new SUV, and then I should be able to bring the frame to work around the same week, so I should be able to make another video either last week of April or first week of May. I'm also trying to use a lot less once again, I made a video without really thinking about it. Use it again. Jesus, I really can't not use The first 15 minutes of this video have every probably 15 seconds. Wow. I think I need some help. I think I need some help. Maybe I should go see somebody. Wow. Okay, that's it. Have a good week, and I hope your Sk-Tank build is going as well or better than mine. Okay, bye.